started here. Really excited to have you all joining here. Welcome, welcome, wherever in the world you're coming from. On this series, we try to highlight things that aren't pure passive house. They could be tangential, and this is a topic that came up a lot in Denver this past week and has been coming up a lot more, thankfully, in our industry. We have Kate Bren here, and she's going to be speaking about embodied carbon and life cycle analysis. I'm very excited for it. I hope you all are too. Zoe's going to introduce Kate, and then we're going to get going with the presentation.
Thanks, Carmel. Yeah, I am also very excited because this is topical and has been for a while. So I'm going to introduce Kate here. As a performance consultant at Cyclone Energy Group, Kate translates highly technical building science principles into actionable steps on high-performing projects of all scales. Kate complements her own analyses and those of others with compelling visualizations and stories. Before joining Cyclone, Kate directed the high performance building department at Passive Energy and consulted with single-family residential clients on resiliency, passive design, and mechanical systems best practices. Kate is an Austin, Texas resident and a graduate of the University of Texas at Austin with bachelor degrees in architecture and architectural engineering. She is also an EIT and an appointed member of Austin's Resource Management Commission. So very happy to have you here, Kate, and please go ahead and take it away.
Hey everybody. Yeah, thanks for having me. I'll go ahead and share my screen. All right, so yeah, I'll just be talking about life cycle analyses and what I've learned so far about them. To speak to my background a little bit more, here's where I've been throughout my short career so far. So I studied at UT, and that's where I first got interested in embodied carbon analyses. I did my undergraduate thesis on creating a way for us to evaluate embodied carbon in grasshoppers. Next, I went to Passive Energy and became interested in Passive House. And then finally, I've ended up at Cyclone Energy Group, and we're based out of Chicago, but I'm remote, and so I'm located in Austin, Texas. All right, so diving right in, let's talk about, I guess, why we're interested in embodied carbon and why it's worth studying. So a lot of you might know something about this, might not know a lot. But so here's a bit to get us all on the same page. So we think about operational carbon a lot in the context of buildings, and that's what the industry has largely been focused on these last few decades. But we can see here that operational carbon is just this blue portion, and then embodied carbon is pretty much everything else. And we can also think about how operational carbon will start to decrease over the next few decades as the grid starts to decrease in its carbon emissions. And so that means that embodied carbon will play an even larger role in buildings in the future. So in life cycle analysis, we measure these 5 main categories. And this is from, I guess, the lead standpoint of things. This is what we like to look at. But so global warming potential is what we associate with embodied carbon. That's the one that you've heard most about. This one is kind of a handful, eutrophication. That one is another one that we measure, and then these other ones, ozone depletion, acidification potential, and smog formation are all relevant as well. Bio-CO2 storage is also one, but LEED doesn't consider that one right now, so I haven't delved into it as much. There are a few different ways that we can measure environmental impact of materials. And so tools take different stances on which environmental impacts they measure. So upfront is considered up to the end of the construction phase, versus whole life is starting from the product phase to all the way to if a building material will be reused or recycled. Embodied carbon, as I guess on a national scale, is getting a lot more attention in these last few years. So here's a map from the Carbon Leadership Forum of different states that have implemented some level of embodied carbon legislation. The most important one to bring up here is this Buy Clean legislation from California. They established maximum acceptable global warming potential limits for all of their governmental projects, which is a pretty big deal. So that's a landmark policy. Cities are also taking efforts to limit embodied carbon as well. For example, Austin, where I'm at, they are attempting to decrease embodied carbon in construction by 40% from a 2020 baseline. Another reason that one might be interested in pursuing a life cycle assessment would be through LEED. And that's the main bulk of what my experience has been from. There are a few different ways to get points with LEED. And so the first one is just to conduct the assessment. The second one is to compare it to a baseline building and show a 5% reduction within 3 categories. And then the third, which would be 3 points, would be to show a 10% reduction. Here are a few different tools that I'm familiar with to study life cycle analyses with. My favorite is one-click LCA, and we'll talk about that in a minute. You may notice the slide feels a little bit incomplete. I was able to find the number of EPDs that one-click LCA has, but these other tools, I'm not aware that they readily publish the amount of EPDs that they have. You can use the one-click and tally for LEED versus EC3 and Passive House Ribbon. My understanding is that they both use that first stage of analysis, which is this upfront carbon, and so that's why they're not as applicable to LEED right now. Yeah, let's move on. Here's why one-click is my favorite. You can do a lot of different things in it. It has a LEED interface integration, as I explained. You can input all of the data from it. It has a pretty wide variety of EPDs from across the world. And then it also has a way to compare the different buildings built within the tool. One-click has been my favorite for those reasons, but there are a myriad of other tools that you can use. And this is a great report that came out from the Rocky Mountain Institute recently, trying to help people understand which tool might be best suited for their use case. Okay, so now let's start to get in the weeds a bit about what happens in a life cycle analysis. So the first thing that I do is identify the materials and their quantities of the materials. And then I'll select EPDs, which are environmental product declarations. And then lastly, I'll compare the proposed building to a baseline building and see if I can get some lead points in my case. There are a few different ways to evaluate materials and quantities. The one way would be to look at submittals. So if you happen to have really good data from your contractor, you can directly look at the quantity of cement and plug that directly into one-click. Another way to do it would be to look at the drawings and evaluate the material quantities in some kind of Google spreadsheet. That one is the most user-friendly I've found when I've been training others on my team how to use it. That's the one that makes the most sense. And then something that I've been playing with is also trying to do it in Grasshopper. And the reason that I'm interested in doing it in Grasshopper is because it's a parametric interface. So in theory, I could build a template that looks like this and then just plug in the geometry, and it would create the analysis a little bit quicker. Next, picking EPDs is the next step. So again, if you've got submittals, you can look directly at those and see if they're specifying a specific product. So for here, I saw that they were using the number 57 stone from Vulcan Griffin, and I happened to be able to find an EPD that reflected that exact product, which is very exciting and doesn't always happen. So here's the kind of other way that you might be able to do it. If you're looking at a drawing and it just says 5/8 gypsum board, you can look for a relatively generic or industry average EPD. So here I picked one that was in this breadth of material selections that we have available EPDs for, that sort of fell within the middle of the environmental impact. There are a number of ways also to think about EPDs and decide whether or not one would be a good one to use. So for LEED specifically, you can't use data points that are expired. And one-click is pretty good about alerting you to those kinds of things. Also, this is built into one-click, just the idea that not all EPDs are created equally. And so there are different verification steps that are involved, and so some are built into tools readily that will prevent you from using EPDs that don't pass their verification standards. And I'll talk a little bit more about this with the case study, but the last way that you can determine if an EPD is worthy of using or not is if the material has an outsized environmental impact in relation to all the other available EPDs. So you can't tell from this image, but there were, I think, 3 EPDs, and then this is maybe like, 100 EPDs. So there were 3 EPDs in here that were performing terribly, and then every other product was sort of within this range. So I think those bottom 3 EPDs would be really difficult to use in a life cycle analysis for that reason. All right, in terms of comparison, here are the different ways that we can compare life cycle analyses in LEED. So there's, you can compare an earlier design phase to a later design phase. This is the ideal if you happen to be a consultant and you're involved pretty early in the project, or if you're the architects themselves. You can compare decisions that you make earlier on to decisions that you improve later on in the process. Similarly to looking at the submittal selection earlier, we can try to look at specific EPDs from the contractor documents, or we can compare those EPDs with the industry-wide averages or generic EPDs. And then lastly, we can look at industry standard construction methods and compare those to unique or specific construction methods within a specific design. And I'll give you an example of that in the case study coming up. Yeah, here we go. So the bulk of the life cycle analyses that I've been working on have to do with warehouses across the United States. And so here's an example of one of those projects. It's got insulated CNU for the first 12.5 feet, and then it's got a metal panel above that with fiberglass batt. Let's see, slab on grade, insulation below the perimeter just at the office. And then the roof is an insulated metal panel. So 2 roof decks with a sandwich polyurethane board between them. So first we identified what materials and quantities were in there. Next, went about the process of selecting various EPDs. So the insulated metal panel was unusable for a variety of reasons. And I'll get more into this on the next slide. So let's just jump there. So I had this EPD that I was really excited about from the product manufacturer of the metal panel that we were using, but it had a 40% higher embodied carbon than if I were to just create the construction myself. So that led me to believe that it was going to be really difficult to use that EPD and show any amount of improvement with LEED points. So I ended up, as I said, building the metal, the IMP myself, and using that instead. The next thing I tried to do was look at a spray foam roof. So this one, as I mentioned before, the proposed case has the polyurethane boards, and in this case, the baseline has spray foam, so it doesn't have that additional metal roof deck panel. But it turned out that the polyurethane boards performed a little bit worse than the spray foam. So this would, typo in here, 0 LEED points. So you can't increase more than 5% in any category, or that's 0 LEED points. So that one doesn't work out either. Next, I looked at a fiberglass roof. So in this case, the IMP roof still performs worse than the fiberglass. So that sort of matches, like, understanding of what we would expect that fiberglass would be a little bit more environmentally friendly than the insulated metal panel. So again, 0 LEED points. Lastly, the best conclusion that I came to was to compare the fiberglass bats that were used in the walls to an insulated metal panel in the walls. And the main reason I did that is because we talked to the architect, and that was a pretty common substitution that they would make. They would either do fiberglass bats in the roof or in the walls when they weren't interested in using insulated metal panels for that reason. So here we're getting 5% or more increases in at least 3 categories, and so that's 2 LEED points. And the main holdup here is that one of the categories has to be global warming, embodied carbon. So that since that one is only 5% increase or decrease, that sort of limits the number of points that you can get for this one. What I'm interested in looking at next. I'm curious to see and learn more about how operational carbon relates to embodied carbon. The Passive House Ribbon tool has a little bit of this built in, and I haven't gotten to play with that at all. So I'd be interested to see what that looks like. I also saw a cool study from Thornton Tomasetti about how adding insulation relates to embodied carbon versus operational carbon. So I think it'd be really interesting to replicate something like that for my project. And I'm curious to see what sort of impact grid decarbonization plays in how we think about embodied carbon in relation to the, I guess, increases in the relevance of embodied carbon and the decreases, perhaps, of the importance of operational carbon. And here are a few resources that I find helpful, and I guess things that I've already talked about. And I think y'all have been posting some links in the chat as well to those resources. So that's all I got. Should I keep sharing my screen while we do questions, or maybe bring it back up as needed?
Kate, thank you so much. This was a really nice kind of crash course. It looks like we have a mix of audience members that have done LCAs or at least compared EPDs in that kind of A stage of life cycle. I think we're going to pause for a quick thank you from our sponsors, and then we'll kick off the Q&A.
Yes. Hi, I'd like to give a big thank you to the fine organizations that make our work at Passive House Accelerator possible. First, a big shout out to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thank you too to our founding sponsors, 475 High Performance Building Supply, Baxt Ingwe Architects, Glavel, Minutair, Mitsubishi Electric Train HVAC US, Partel, Rockwell North America, Stocorp, and Zola Windows. And thank you to our champion sponsors, Bewiso, Icon Windows and Doors, Intelligent Membranes, Prosoco, and Source 2050. And thank you to our patron sponsors, Brennan, Coltraco Ultrasonics, Euroline Windows, Holstrom System, Inotech Windows and Doors, Lamelux, Owens Corning, RDH Building Science, Sanderson Sustainable Design, and US Engineered Wood T-Stud. Thank you, sponsors.
Starting into what's next and what you're curious about. Is there anything else you want to mention? I mean, we like to, of course, ask what you think is next in terms of high performance building. Anything else you want to add or expand on the points that you just put up?
Yeah, I guess I feel like the conversation will be more directed to how do we relate embodied carbon to operational carbon, as opposed to maybe looking at just the energy that's been used, when it has been used, because the grid is dirtier at certain parts of the day than it is in other times of the day. And I guess this would be hard to understand, but how does adding more insulation or more air sealing relate to that operational energy usage, and then are you getting a payback basically in carbon from your insulation if you relate it to both embodied and operational?
Yeah, I totally agree. And also thinking about when we can look at grid interaction and how you can compare more nuanced operational energy maybe with your embodied. And then we see all of these graphs of if you do a new construction to code building, this is what your operational versus embodied looks like. And then would love to see so much more in terms of retrofits or super high performance and get more case studies there. So yeah, please keep sharing more information with us.
Sure. Yeah, and that RMI graph that I put up, that it's linked in the report as well. They had a tool that was specific for doing retrofit LCAs, which I thought was really interesting that I haven't looked into. So I think there's some resources out there that could help us learn more about that as well.
All right, so we'll dig into our queue of questions. First up, we have Shelby. Shelby, do you want to unmute yourself?
Sure. Yeah. Hi, Kate. Thank you for your presentation. So my question is if you've done an LCA before for a project that is pursuing full living building challenge standards.
I have not. That's something I'm interested in. I do look at a lot of those I guess analyses. I do living feature auditing, so I'm familiar with them. But I guess it's interesting. I'm not sure I have a lot to say on the topic right now, but I'd love to get back to you on sort of the differences between like the LEED standards and the living feature standards, because they are a little bit different. Do you have some experience yourself?
So yeah, my husband and I were trying to build our home to full living building challenge standards as well as Passive House. And then so I just recently delved into EC3 to create a baseline for our project because we have to show that we're better than the baseline for our project. But there are a lot of intricacies that go into that energy and embodied carbon reduction imperative. So yeah, I was just seeing if you had any experience with LCAs for LBC. So yeah.
Shelby, do you want to share any more of your experience with that? I mean, maybe we should have you talk longer in some other, segment or something about your experience with Living Building Challenge. But in the context of LCA, is there anything you've learned that you want to share?
Well, my background is not in building science whatsoever. It's something that I've been learning as my husband has an architecture background, but I do not. So EC3, out of my perspective, was coming at it without having a background. It was kind of easier for me to understand. And also it's free. So that was also super helpful. But it was kind of intuitive in a way that once I started playing with it, I learned more of how it worked. And I watched a couple tutorials, but it was an easier beginner one, I think. I tried Athena before, and Athena was harder. So EC3, I think, was kind of more along my line of understanding. I haven't used Tally before, but I know William, my husband, would like to try using that one instead. So yeah, but
I'm curious what made EC3 more user-friendly than Athena from your perspective.
I think so. For EC3, we got permission from the Living Future Institute to use my parents' home as our project baseline because it's the same square footage and occupancy type. It also matches most of the homes in our area as far as culture and community goes. So I measured everything. So I just measured our concrete foundation, and I measured all of our interior walls and the plywood and gypsum board and drywall, everything, vinyl floors and carpeting. And I was able to plug in all of those numbers into EC3. And EC3 had a calculator for input for certain things, like they had one for insulation. So I could kind of go in for the square footage of the insulation and then the overall R value that was required at that point in time when my parents' home was built. And then they were able to calculate the embodied carbon for that. And then I took, because it was the baseline, I just took the general overall conservative estimate that EC3 was able to give to me for as far as EPDs and the amount of embodied carbon they had for those materials. So it was pretty basic. And to be honest, I'm not even sure if I did it correctly. So that's another reason I was seeing if you, Kate, had experience, because we'd be interested in hiring somebody with more experience to come on and kind of help us, guide us through that process too. So, yeah.
And it looks like Valentine chimed in there to recommend trying Beam, as it's now accepted by ILFI. All right. Carmel, did we lose you again? We have lost Carmel's internet, so
I'm hanging on by a phone hotspot, so hopefully it's not too bad. And yeah, I think we're getting to our second question in the queue, a name of which I'm not going to attempt to to butcher the pronunciation of. Weijia. If you are on and had a question. Yeah, there you are.
I'm Weijia. Yeah, hi.
Weijia,
Yeah,
nice to meet you.
me too. So our firm is doing some internal embodied carbon study with using EC3, and also we have a license of Tally LCA. So our workflow is exporting from Revit with LCA to do the quantity takeoff and assign the material EPD in EC3. I guess one question is you mentioned that you like the one-click LCA more. Maybe I missed. I just wonder what was the reason that you didn't use EC3? Because for us, we do find problem using EC3 that because our project types mainly is affordable multifamily housing that is built with pre-stressed concrete planks and CMU and brick facade, which we don't find a lot of EPDs available. The other question is, do you have any experience at using the Tally Cat beta that's also like can work with EC3? Yeah.
I don't have experience with Tally Cat, but I'm very interested in it. I think the earlier version of Tally, as I mentioned, has just a few EPDs. I think it has around 200. So I feel like the Tally Cat will be a lot more user friendly since it pulls from the EC3 database, which will be really interesting. I guess my preference for one click comes from, I think, well, and I'm curious to hear more about your perspective as well, but my understanding is that LEED requires all the whole stage, all of the phases that we talked about in the beginning to be used in order to submit. So I think we can't technically, from my knowledge, we can't use EC3 to do life cycle assessments for LEED. So one click is one of the tools that has the whole life stage of the product. So that's the main reason that I'm interested in it. And then I think a few other reasons as well, and you're probably finding this as well with Tally, is that I like that there are a number of different ways that you can give one-click LCA information. So I can directly put in quantities like you would in EC3. I can also upload an Excel spreadsheet, which is what I'm trying to figure out how to do right now. I can, they have a Grasshopper plugin. Let's see, I haven't tried to do the Revit export in Tally, and I'm interested if you want to provide some perspective on like how that goes. Yeah, Tally seems really interesting. I think, yeah, the lack of EPD surprised me. So I think that the Tally Cat version will be, a great step.
Yeah. I mean, I think the Revit export function from Tally LCA is pretty smooth, I would say. But we do need to maintain a good practice of like Revit, like hygiene or file organization or family creation. Yeah, we tried the Tally CAD, but it seemed like it reads a lot more family information. It's like we have to like even further like define the family than what we currently do. That's why we kind of stopped it. We kept it just in Tally LCA instead. It just like we don't have a good enough Revit family standard to use Tally Cat. Yeah, that's our experience so far. Yeah.
That's interesting. So it seems like, and maybe Shelby was saying this too, but with EC3, you can kind of get a range of potential like environmental impacts for a given product that's not necessarily super specific. And then you can sort of assess from there versus like with one click, you're picking an EPD and you're like going with that one EPD. Is that what it sounds like? Yeah, Shelby's nodding.
Okay, sorry, my camera is not working this time. I just disappear sometimes, but thank you.
All right, thank you. These are good practical discussions, I think probably helpful for a lot of people on here. Here's a question. How do you know whether an EPD is legit? And how do you vet your EPDs and determine whether they're comparable to another EPD?
Yeah, so my favorite way to do that is within OneClick. There's a way to compare each of the EPDs to each other, and you can even compare EPDs from the United States to EPDs globally, because I think Europe is way farther ahead of us in terms of producing EPDs, just in terms of the volume that they have. So it's helpful to look at the EPD in the context of others. Like in that case study, it looked at the insulated metal panel, and it just seemed like it was just astronomically unrealistic in terms of the global warming potential. So I think it's helpful to just put the EPD into context with others and to better understand if it's going to be a good one for your project.
And I'm going to follow in with another question in terms of gauging timing. You had that slide on the different, I guess, timelines that LEED looks at in comparison, early design, schematic design. What is the right or best time to start an LCA to actually have impact on decisions made on a project? And then if there are more assumptions, the earlier that you start, how do you go back and reconcile once you have specifications and submittals, or do you go back?
Yeah, that's a great question. Certainly earlier on in the process, you won't have that specific submittal type information, but you can point out big things like if they're using concrete versus steel versus wood. So I think that would be a really good time to make those kinds of moves. And LEED would credit you for consulting earlier on. You can reference an earlier design of the baseline to a more developed version of the design. So yeah, I think it's difficult to look at the submittals and then kind of backtrack. But I've mostly been getting in at the stage of LEED submission as of now. So we are having to look at the submittals and then relate them to some sort of industry average, or relate the construction methods that they're using to another typical construction method. So I'd say there are a variety of different ways to do it, but I think I'm educating myself as a consultant in doing those two things that I just described. But if I were to educate the client more, I would be getting involved earlier and trying to make those changes earlier on in the design.
And as a follow-up to that, and maybe this is a bit of a touchy question, but if someone couldn't afford hiring an LCA consultant, what are resources you would point to them to get that overarching, this is better than that kind of guidance?
That's a good question. I'm not sure that there's, I guess I'm not aware of a resource that sort of says this is better than that. But I do think others, and I mentioned in the presentation that I think there are a few resources out there that are free. There's certainly a free version of EC3, and then there are a few free trials as well that they could try. From my experience so far, it seems like fiberglass is better than spray foam or polyurethane boards. So that's kind of one example that I could give you, but I guess I think it's a spectrum of what's the worst material to what the best one would be, and so where does your material fall along that spectrum?
One thing that comes to mind for me is looking at what's locally produced, and maybe it has to be transported less if you're looking at equal materials or products in other senses, what's closest to you? What can you not transport as far? Or maybe what's lighter, again, in terms of transportation, what's going to be less fuel intensive in terms of transport. And that goes again with like EPDs and what are they including and not including. Like, you know, when you're comparing them, they might be looking at like cradle to gate, but not necessarily all of your transportation to site. So that's one thing that I kind of like to look at. I mean, kind of a tangent, but I did like a little study on steel. So I was working with a kind of developer who really was intent on using steel for their design, but wondering how to reduce embodied carbon. And, you know, the main things were like recycled content and where are you getting it? And of course, using like electric arc furnace. So it's like all of those things together. But like when you're looking at something equal, those seem like pretty big factors to me. Yeah. Another question here. Can you elaborate a little bit more on like your process when you're working with clients? Like, I mean, it to me, it seems like it could be like pulling teeth if you're trying to get all of the submittals that you need. Like, what submittals do you end up asking for? What are the major ones? And how do you make sure you get them? Are you like hounding the contractors, or like what does this look like in reality?
Yeah, I'd say it starts with the architect, generally speaking, and if they can get me the information that I need, then I'll go from there. Sometimes it's as simple as like, what kind of insulation are you using? Because a lot of times we'll get drawings and we have no idea. Like it just says, you know, rigid insulation. So even I don't know, there's a lot of different levels of information that you can get, and every point in the process will be helpful. With the submittals, I tend to go for insulation improvements over, I guess, structural ones. You mentioned like recycled content, and then you can also, you know, have some like concrete additives. And I'm not seeing a lot in our submittals about those specific parameters, so it's a little bit more difficult for me to relate the structural materials to relevant EPDs. But with the insulation, it's more clear as far as we're comparing different types of insulation as opposed to and I guess an insulation with like more recycled content versus less. So those are more like straightforward approaches when we don't have as much information to go off of. Yeah, and also I guess on the transportation thing, I learned at a conference recently, and I guess this is related to my own experience as well. The transportation category is not, I guess, as big of an impact as we think it is. And so I do think it would help to get like stuff locally, but maybe you'd see a big difference if you're like importing granite from Italy versus like getting it from next door. But I think across the country, like just gas is not super carbon intensive compared to all the other things that are going into your materials. So I found that really interesting that that's not like necessarily the biggest lever to pull.
That is really interesting.
Magnitude of scale matters, right? And I think there was a good like underlying suggestion here is that like at least start with focusing on one material or component, even if you're not doing a whole building life cycle assessment like that. Focus in that one for one on insulation, on steel, on concrete is a really great place to start. Okay, we have a couple of other questions flowing in. Next up, if you're able to unmute yourself, Rob Blount. And if not, happy to ask the question.
No, that's fine. I just took a second to find the mute button. My question was just about data sources for Tally versus EC3, Athena, et cetera. I know that, in Denver last week, I think I had this conversation half a dozen times. What I found is typically the tools that plug directly into the rest of the software that we use don't necessarily have as up-to-date or as accurate a data source as EC3 or beam if you're looking for something light on the beginning end. And I was wondering if you've seen any analysis to kind of prove that out, or how often you take a look at what those, when you trace the source data back, what's it look like?
Yeah, that's a really good question. And I'm not sure I can speak to it exactly, but I have learned that when I'm making comparisons between specific EPDs, it's really important that the upstream database is the same, because sort of like you're mentioning, like there are different standards for different upstream databases. And so it's like the quantities might just be vastly different. And so the LCA might be like improportionately weighted towards, one result over another just because you changed the upstream database. So it does seem like there's a bit of an issue there in terms of this standardization, and maybe the one that you're bringing up as well is just the age of the data and how relevant it is.
Thanks.
And next up, we have Mary James. There you are.
Hi. I was just curious, Kate, because in your analysis, fiberglass bats came out slightly better than the insulated metal panels. But my understanding is, that effectiveness is going to be better for the insulated metal panels than the installation of fiberglass bats, which often, can have a problem because they're not installed perfectly on site and they don't insulate as well as something that was created in a factory. And I just wondered if you're looking at a whole life cycle analysis, does any of that get taken into account at any stage?
That's super interesting. I don't think it's being taken into account. I think that's not even necessarily something that I would expect to show up on an energy model. So I feel like that's kind of why we need, I don't know, experts like you guys in the room to be like, this may look better on paper, but in reality, you're going to run into problems, or the install is not going to work out very well. So I feel like that is certainly like a limitation of the tools that I'm familiar with, that you can't understand the contractor's perspective necessarily.
I mean, another part of that is like, Mary, were you getting into like end of life and recycling? And because that often is, outside the scope of a lot of life cycle assessments where you're reusing or.
No, I was thinking more of when you're comparing the impact of your materials choices on operational versus embodied carbon emissions, but then if it's affecting the actual performance, as on paper it looks better, but maybe in reality it's not actually performing better on that part of the analysis. I don't know.
Yeah, that's such a good and hard point. And to Kate's point, our energy modeling is flawed in the sense that not only is it not perfectly accounting for installation, if you're wanting to account for compression and voids and all of that, that could happen with like a fiberglass bat material, but also we can talk about the validity of our values, right? And the long-term thermal resistance and like testing over time, right? So if we're looking at a foam product that has an upfront R value that looks really, really good, and you think you're going to be saving and operational, and you're kind of weighing out that versus better from an embodied carbon standpoint material, you might actually 20 years later be performing worse than that better, less intense embodied carbon material because either don't have the test data that goes out that far, or you didn't use the very conservative R value that you should have based on how that material ages. But that's such a good point, and further why that's such a delicate balance. And I didn't add this to the queue, but we did have a question from Mike Wong, if you're on and able to unmute yourself.
Hi, everyone. Let me just read what I wrote. I'd like to get some clarity regarding the scopes of services as it pertains to architects. What else should we take on other than choosing materials with the correct EPDs, modeling them in our design with something like OneClick or Tally as a plugin to get a quantity for our projects? There are aspects that go well beyond our knowledge base, and things like when we get together for meetings, our commutes, and then additionally, end of life of the project itself. That's not something that we've been trained on. And so for a whole building life cycle assessment, we're actually being tasked with figuring that out. And I imagine that, LCA consultants like yourself will help facilitate and fill in the gaps of where what we know and what we will eventually know. I also understand that, LCAs and everything, we're all in nascent stages of development and things will become more developed. But what do we do if we are given a project today?
Yeah, that's a super interesting question. And I think it's a big one. It's sort of like, yeah, how do we think about carbon in a larger sense? So I guess there are a few different scopes that we can think about measuring carbon in. And I think it's, I don't want to misspeak, but one scope basically has to do with directly your emissions on site, like related to your building and the building's operations. And then there's another scope related to the utility and the energy that you're getting from them. And then the third scope would be like indirect emissions. So yeah, transportation, commuting, flying, all of those sorts of things. I'm certainly not the expert on how to calculate all those different scopes. But I am hoping I would believe there are people out there who would have that kind of information. I guess my instinct would be at a certain point, we know that our buildings are going to produce an amount of carbon in construction and over their life cycle. And no matter how much we try to reduce both the embodied carbon and the operational carbon, it won't be zero. So we can aim for like net zero by purchasing like offsets and RECs. There's a whole other conversation there about like the validity of offsets and RECs. But I think it's kind of a can of worms. But I do think it's worth evaluating. Yeah. Anybody else have any thoughts on that question?
Yeah, one of the things our firm was trying to parse is, what do we do? And so from an embodied carbon point of view, it seems straightforward, we think, in that we pick the right EPDs, we model that, we get quantities with a plugin like OneClick or Tally, and then we have a big giant spreadsheet that the plugin produces, and we get quantities for that. But then outside of that, for embodied carbon, what do we need to know? Some of our folks were talking about, product category rules and not knowing where that fits in. And so, and some of us have different ideas about that. So there's a debate going on as to what is really our scope. And hopefully LCA consultants can just tell us what it is.
I would hope so too. Yeah, I think that's a difficult question to answer. Yeah, I'm not sure.
Yeah, it's an ongoing question. Other people are asking the same questions and having a hard time coming up with answers.
Yeah,
I think that. Go ahead, Zoe. I was just going to say that. Thank you, Mike. I wanted to further your point because I think even like regulators and investors and people like setting some of the standards or some of the goals are having a hard time reconciling that, even deciding between like scope 1, scope 2, scope 3, right? Like what's the limit of what you're going to get incentives for or what you should be tracking. My feeling, and I think the passionate feeling of the community, is like anything your firm can decide to do as a firm decision, because you know that this has a positive impact on scope 3, which is not calculated, but like is known to, have some sort of impact, is always a good thing to be talking about. And that's a good argument to have, even if you don't find a resolution.
One more
and
thought
I
in
think,
relation to
sorry, Zoe. Yeah.
Kate, go for it.
Sorry. Yeah, one more thought in relation to that regard is, when I'm conducting a life cycle analysis, there are a ton of materials that are going into the analysis that are having like less than 0.5% of an impact. So I think it's important too to consider like where your biggest impact could be. Like even though we can, you know, calculate and record all of this data, I think maybe from a gut instinct or even from like just looking at scientific papers, like we know that, you know, taking an international flight is a huge carbon footprint. So like what are sort of the things that we can do that are like more instinctive and less based on having all of the answers, so like all of the questions that could kind of make those larger impacts.
Great. Yeah, I think this is kind of an existential question too. Like what is in scope and what is out of scope, both for EPDs, because different even certifications for EPDs kind of define things differently, as well as life cycle assessments as a whole. And even right now, like we're probably just talking about global warming potential with the metric of carbon equivalent. But then, of course, Kate showed all of these, what is it, 5 or 6 different metrics included in an LCA, and we could decide we care about those as well, which we all probably do, but we're not quantifying quite as much. So anyway.
Our next month's session will have Amanda Bonelli, a project manager and CPHC at Philadelphia-based Bright Common. Hope to see you all next month. I want to thank Kate so much again for her time, and all of you for getting involved in the discussion. Hope to see you next month and stay in touch in the meantime.
Thank you.